Okay, so I'm going to solve this system of equations by graphing. And in order to do that, I want to put each of these equations in slope-intercept form. So the one that looks a little bit easier to me is this one, the second one, and so I'm going to start with that one. And so I'm going to subtract 3x from both sides in order to get the y all by itself. And then I'm left with y equals negative 3x plus 18. And this is in slope-intercept form. This y equals mx plus b, where m is the slope of your line. And so I'm also wanting to put this one in slope-intercept form as well. So I'm going to need to subtract 3x from both sides, and it would look like 5y equals negative 3x plus 30. And then I would need to divide by 5 on both sides. And I'm left with 5y equals negative 3/5 x plus 6.
You will need to report to the Advanced Opportunities Office. That is room E120 right outside.
These are my two equations that are in slope-intercept form, and I'm going to go ahead and graph this.
Senior do not come to school till 11:15. Everyone else must be here. Thank you so much. And then we have one more announcement for NHS. At the end of school,
now this one right here, y-intercept is all the way at 18. It's on my graph. I don't want to do tick marks all the way up to 18, so I'm probably going to go by 5s. 5, 10, 15, 20. And so it's going to be just below 20 at 18. And my slope is negative 3 over 1. If there's a whole number, like negative 3 is actually an integer, you would just put a 1 underneath it to figure out what the length is that you would need to go down. So I'm going to go down 3, and remember these are all by 5s. So 1, 2, 3 would actually get me all the way down to 15 over 1 right here. And I'm just going to draw a line and extend these. And so I have my line here. And then my second equation, I have my y-intercept is at positive 6, and I'm going to go down 3. Down 3 would be at positive 3, and then over 5. And here is my graph. So this is what I'm really worried about as far as seeing it on your work. I want you to be able to graph these two equations, and if you're able to graph the two equations, you'll be able to see that they intersect at one point. And so this would be one solution, and you can estimate where that does actually hit. It looks like it might be something like 7, 2. But I'm not as concerned about this. We have the other methods that we're going to talk about, substitution and elimination. But what I really care about is this graph, and that you recognize that this is going to hit at one equation. Thanks.